Assalamualaikum and a very good afternoon. Right, so for DRS student, I would like to say sorry because we couldn't make it face to face for this chapter 8 and 9. Okay, chapter 9 for BSK. Okay, actually this one is for DRS, it is chapter 8, complex geometric titration. Since this week, I have LI evaluation, okay, for your seniors who undergo their internship. So I have to do evaluation for them for this week. And then next week, I have evaluation for final year project students. Okay, so that's why I have to record this chapter 8 and 9 for you guys. Okay, so let's start with chapter 8, which is complex geometric titration. Okay, so for complex geometric titration, of course, the first thing that you need to know and to understand is the definition. Okay, so titration method is the same. So you use burette and conical flask to do the titration. Okay, the titration method is the same. The one that is different from other titration is that what is you use as your titrant and titrant. Okay, so what is in the burette and what is in the conical flask. Okay, so in this case, for complex geometric titration, you are doing a reaction between metal ions, and complexing agent, or we call it as ligand. Okay, so this is the metal ion with charge. Okay, since we call it as ions, it should have charge. Okay, so positive charge. We only do complex geometric titration with cation. Okay, positive charge ions. And the ligands are uh, denoted as L here. So L is for ligand. Okay, so let's see what does it mean by ligand. Okay, ligand is the donor species. Okay, donor species means that it has to have at least one pair of unshared electrons available for bond formation. Remember last time, okay, I said that to form a bond, there must be two electrons, or two electrons, we also call it as pair, one pair of electron. So the unshared electron here means that, for example, in H2O, okay, H2O, it has one oxygen with two hydrogen, but still this oxygen has two unshared electron, two pair of unshared electron. So this unshared electron, at least one of them, one of the one pair of the unshared electron is available for bond formation with the metal ions. Then we call this species, or we call it this compound as the ligand. Okay, as long as it has at least one pair of unshared electron, and this electron can be used for bond formation with the metal ions, we can use it as a ligand or the complexing agent. Okay, to undergo the complex geometric titration. Okay, an example of other ligands, instead of water, we have NH3, we have chloride ion, bromide ion, and also EDTA. So this EDTA, we are going to see what is EDTA after this. Okay, and then other terms that used in complex geometric titration is the chelate. Chelate is produced when a metal ion coordinates with two or more donor groups of a single ligand to form a 5 or 6 member heterocyclic ring. Okay, so here you might confuse, okay, with the definition. Okay, let's see. This chelate is formed when a metal ions already coordinate with two or more donor groups. Okay, for example, EDTA. Okay, this EDTA has many donor groups. Okay, EDTA has 6 donor group. Okay, and this two or more donor group must come from a single ligand. The same ligand, okay, one EDTA has 6 donor groups. Okay, and and when they have 2 or more donor groups, they can form 4 or 5 or 6 member heterocyclic ring. Okay, let's see one example here. Okay, like this one. Okay, so this ligand, it has 2 donor group, 1 and 2, but it comes from a single ligand. Okay, dia satu compound tapi dia ada 2 group yang boleh form bonding with the metal ions. So when they form bonding with the metal ion, so this is the metal ion. Okay, when they form bonding with the metal ion, it can form 5. Okay, 1, 2, 3, 4, 5. 5 or 6 heterocyclic ring. Okay, this is what does it mean by a chelate. Okay, it's already formed bonding with the metal ions, and when it form bonding with the ligand with 2 or more donor group, they can form 5 or 6 heterocyclic ring. Okay, kan boleh nampak macam bentuk ring kan. Okay, so dia ada 5 lah. Satu donor tapi dia ada 2 atau lebih donor group, dia boleh form ring with the metal ions. Okay, but syarat dia adalah 2 or more donor group from a single ligand. Satu ligand tapi ada 2 atau lebih. Okay, to form a 5 or 6 member heterocyclic ring. Okay, as you can see for water above, okay, it has only 1 donor group. Oxygen je yang ada unshared electron. So this one cannot be classified as chelate. Okay. Alright. Okay. Next, chelating agent. Okay. This chelating agent is an organic agent that has 2 or more group capable of complexing with a metal ion. Okay, samalah lebih kurang dia punya definition. Okay, so this one is towards the chelating agent. Okay, agent tu sendiri. Yang chelate ni dia dah combine dengan metal ions. Dia dah form bonding dengan metal ion, chelate. Chelating agent adalah ligand tu sendiri. The ligand that has 2 or more donor group capable of forming a bonding with a metal ion. Okay, so most widely used chelating agent is EDTA. So what is EDTA? Okay, after this we have the definition of EDTA. Right, so we go to another 2 terms used in complex geometric titration, which is unidentate and bidentate. So a ligand or a chelating agent, a ligand. Chelating agent dia kena ada 2 atau lebih donor group, but a ligand, okay, kalau dia ada 1 je donor group, kita panggil dia ligand. 2 atau lebih pun kita panggil ligand juga, tapi nama lain dia boleh jadi chelating agent. Okay, a ligand that has a single donor group is called unidentate. Okay, for example, water and ammonia. Water H2O and NH3. They only have 1 single group. Okay, kat sini 1 je oksigen je yang boleh buat forming bonding with the metal ions. Kalau untuk ammonia, nitrogen sahaja yang boleh forming bonding. So this single donor group, we call it as unidentate. Whereas a ligand with 2 groups available for covalent bonding is called bidentate. Okay, kalau ada 2 macam glycine ni, kita panggil dia juga bidentate. So ada beberapa nama lah. Okay, ligand used for general compound that can form bonding with the metal ions. But chelating agent for those who have 2 or more group that can use their unshared electron to form bonding. Okay, and then for a ligand that has only 1 donor group, we call it as unidentate. Ligand with 2 donor group, bidentate. Okay, and then for EDTA just now, as I said, this EDTA has 6 group that can form bonding with a metal ion. 1, 2, 3, 4, 5, and 6. So we also call it as hexadentate ligand. Okay, so depend on how many group that have unshared electron and can form bonding with the metal ions. Okay, kalau satu unidentate, tapi unidentate dia tak boleh jadi chelating agent lah, sebab chelating agent dia kena 2 atau lebih. Okay, and then ligand with 2 donor group, bidentate, and also we can also call it as chelating agent. Kalau 6 macam EDTA, hexadentate. Okay, so what does it mean by EDTA? Tadi saya sebut EDTA. So the full name of EDTA is ethylene diamine tetraacetic acid. Okay, and it is in the group of aminocarboxylic acid. Okay, we can also, if we use EDTA, we can also call the complex isometric titration as aminocarboxylic acid titration. Nama lain lah. Okay, sebab dia je yang selalu kita guna untuk complex isometric titration. Okay, so as I said just now, EDTA has 6 potential sites for bonding a metal ion. Okay, 4 carbonyl groups, 1, 2, 3, 4, okay, carbonyl group, and 2 amino groups, 1, 2. Each of the latter with an unshared pair of electron. Okay, dia ada unpaired electron kat sini. So kat sini kita tak panggil dia oksigen lah sebab dia adalah COOH, dia carboxyl group. Okay, yang ni kita tak panggil dia nitrogen macam amonia tadi, kita panggil dia amino group. Yang ni you guys belajar dalam organic chemistry lah. Okay, so next we go to the indicators for EDTA titration. There are there are 3 indicators for EDTA titration. We focus on EDTA titration and there are 3 indicators that you need to remember. Okay, usually we use organic dye as a metal ion indicators. First is fast sulfone black. This is the name for the organic dye, and this fast sulfone black can only be used for copper determination. And the color changes from purple, the solution will change from purple to green after the titration. And then we have Aerochrome black tea, another name for the organic dye, and we use it for calcium and magnesium determination only. Okay, nanti kalau soalan tanya yang mana kita guna untuk calcium and magnesium, there are 2, Aerochrome black tea and also calmagite. Kalau copper, satu je, fast sulfone black. Okay, and the color changes is different. For Aerochrome black tea, it is red to blue, while calmagite, it is sometimes we see it as wine red, sometimes we see it as purple. Okay, ini faktor cahaya lah, and it turns to blue. Okay. A typical titration used in the lab is the reaction of magnesium 2+ ion with EDTA at pH 10 with calmagite indicator. What happened is that the magnesium with the indicator, okay, it combined with the indicator, it will be red color, and then react with the EDTA, it will form the magnesium EDTA. Okay, so this magnesium EDTA is colorless, but the one that change the color is the indicator. When it reacts with magnesium, it is in red color. But then when the magnesium react with EDTA, now the indicator become will be alone. It will turn into blue. So this indicator is the calmagite. Right, and then this is the steps. Okay, what happened during the titration. Okay, as usual, when we are talking about titration, we will have titration curve. Now, we are looking at the EDTA titration curve. Okay, the titration reaction is between the metal ion. Okay, depends if it is magnesium, this M will be Mg. If we are titrating the calcium ion, this M will be Ca. Okay, react with EDTA and it will become metal with EDTA. Okay, so the titration curve is a graph of PM. Okay, remember acid-base titration pH. Precipitation titration is PCl. For EDTA titration, it is PM. This capital M refers to the metal. It will change depending on what metal is reacted with the EDTA. If calcium, this one will be PCA. If magnesium, it will become PMG. If copper, it will become PCU. And this PM, we know that the small p refers to negative log. And the capital M here is the concentration of the metal ions. If calcium, so this concentration will be concentration of calcium ions. Okay, so negative log the concentration of metal ions versus the volume. Again, volume, and depends what is the titrant that you use. In this case, for complexometric titration, it is EDTA. So at the x-axis, you have volume of EDTA versus the negative log of concentration of the metal ions. Okay, as I said, they are similar. So just now I said that when you have a specific metal ions, for example here you have calcium ion, okay, this PM will be PCA. Okay, so negative log the concentration of calcium ions. Okay, it is at the different pH. Okay, and you can see that the curve also different based on the pH. Right. Titration methods employing EDTA, okay, similar to precipitation titration. There are few titration methods employing the EDTA. Okay, it's either the direct method. Okay, direct method. You can directly titrate the titrant and titrant. There are also potentiometric methods where you use the electrode. And we also have spectrophotometric methods. Okay, it is a measurement of UV-Vis absorption. Okay, after you do the titration, you put them in the UV-Vis. Okay, for direct method, it is the changes of color of the indicator. And then we have another two titration method for EDTA. We have back titration. Okay, remember for precipitation titration, we have Volhard, which is back titration. So in EDTA titration or complexometric titration, we also have back titration. And the method is the same. But the one that is different, what you use as the agent. Okay, in precipitation titration, what you use for the precipitating agent. In complexometric titration, what you use as the complexing agent. Okay. And the last one is displacement method. You displace the ion that you want. Okay. And this is the calculation involved for complexometric titration. Okay. Example, you are given 50 ml unknown sample solution. Analyze for hardness using complexometric titration. What does it mean by hardness? Some of you might be similar with the words water hardness. Water hardness, we determine the content of calcium in water. Kalau you biasa mandi, rambut you jadi keras. Dalam air tu maksudnya tinggi dengan calcium carbonate. That will cause the hardness of the water. Ataupun kadang-kadang kita boleh nampak daripada dalam air tu ada, kalau you biarkan air tu lama-lama dalam cawan, you boleh nampak white precipitation. That one is calcium carbonate. Okay, and it cause the water hardness kalau kena rambut you keras. Itulah. Okay, so this water hardness is determined by the jabatan air. Jabatan air biasanya akan look at the content of calcium in the water to determine the hardness. Kalau banyak sangat, kena complain lah. Okay. Dia ada dia punya limit dia, berapa calcium carbonate in the water should be. Okay. Because it will cause other problems. Okay. Clotting lah, macam-macam lah. Okay. So to determine the water hardness, the content of calcium carbonate in the water, we can use complexometric titration. Okay, so we have 50 ml unknown sample. Okay, and then we require 25.55 ml of 0.01 molar EDTA solution for complete reaction. Okay, maksudnya complete lah, and dah capai endpoint. So this question asks you to calculate the hardness of the sample in molarity. Means that the concentration of calcium ions. Kalau dikata calculate hardness. Okay. In molarity maksudnya dalam bentuk concentration. Ada juga kita minta you calculate hardness of the sample in gram. Maksudnya mass of the calcium ion. Okay. So you are given the chemical formula, okay, chemical reaction, and we know that when we are talking about water hardness, it involves calcium ion. So this calcium ion will react with the EDTA, okay, EDTA in 4- in the form of ion, okay, and you will get the calcium EDTA 2-. So you are given the volume of the unknown, which is 50 ml, while you need only 25.55 ml, 0.015 molar EDTA to completely react with the 50 ml calcium. So determine the molarity. Okay. So first what you need to do, okay, similar to previous chapters, okay, for precipitation titration, the first one we need to calculate the number of mole. In this case, the information given is for EDTA. So we can calculate the number of mole for EDTA. Okay, and after we get the number of mole for EDTA, we can now calculate the number of mole for calcium ion based on the chemical formula given. In this chemical formula, we know that 1 mole of calcium react with 1 mole of EDTA. So the number of mole will be the same. And from this number of mole, we can calculate the molarity. Since we know the volume of the calcium ion, 50 ml, so we can straight away divide the number of mole with the volume of calcium ion. Then we get the molarity of calcium ion. Okay, so we call this as the hardness in molarity. But usually hardness we will calculate in gram. Okay, lagi nampak lah kalau kita cakap dalam bentuk molarity kita tak nampak, tapi dalam bentuk mass kita boleh bayangkan banyak mana kalsium yang ada dalam air. Okay. But they are similar, depends on the question. If the question asks you to give in molarity, so molarity lah. And then, as I said just now, sometimes usually we report the hardness. Kalau jabatan air tu dia report dalam bentuk milligram of calcium carbonate per liter. Okay, so we have number of mole. Just now we can use this number of mole to calculate the mass of CaCO3 by multiply with the molecular weight of CaCO3. 100.09. Okay, so we get the mass. From this mass, we know that there is 0.0384 gram of calcium carbonate in 0.05 liter or 50 ml of water sample. Kalau 50 ml sikit kan? Kita ada 0.0384 gram. Kalau kita ada 1 liter, berapa? Okay, so we divide by the volume, we can see that we have 767 milligram in 1 liter of water. Okay, so banyak mana? Boleh bayangkanlah 700 milligram. Okay, kalau you ada 1 gallon air, you boleh nampak lah white precipitate of calcium carbonate. Okay, so this is the hardness. Okay, we use complexometric titration to determine the water hardness. Alright, so that is for complexometric titration. Okay, and we can also use the same methods for precipitation titration to come up with the titration curve. Okay, kita boleh tanya juga. So we can ask you to find the PCA at the before the endpoint, and then at the endpoint after that in excess. Okay, so boleh come up cara kira dia sama dengan precipitation titration. Okay. Alright, so for the last chapter for DRS students, this one kalau BSK dia ada satu subjek lah. Okay, but you guys for diploma level, we put it in one chapter. We have screening all the important things for instrumentation analysis. Okay, if you guys are going to register for BSK later on for your degree, you will learn more on this instrumentation analysis. Okay, so the introduction, as I said last time, analytical chemistry. Okay, we focus on the chemical analysis. Okay, we analyze what is the concentration of the chemicals in the sample. For example, what is the concentration of drugs in the urine sample? Okay, something like that. So forensic is very similar to analytical chemistry. Wastewater treatment analysis. So we analyze compounds in wastewater. We analyze compound in the river. Okay, so those are chemical analysis. So we have two methods to analyze our chemical. First is the classical method where you use chemicals, balance and other common lab apparatus in the lab. Okay, this one you have done a few times, okay, for your analytical chemistry lab. You are using chemicals, balance and other common lab apparatus. So this one is classical. Okay, the titration can be classified as a classical chemical analysis. Okay, they didn't use, you are not using any advanced instrument. Okay, and then another method for chemical analysis, okay, we use instrumental. Okay, we also use the other apparatus in the lab, but we combine with the use of analytical instrument. Okay, for example, gas chromatography, the high-end instrument. Okay, and often this instrumental instrument is electrically operated. Okay. Next, okay, still in the introduction part. Okay, there are computerized and automation instrument. Okay, we narrow down to the instrumental part, instrumental method. We have computerization and automation. Okay, what are computers? commonly used for data treatment and to control operation of the instrument. Okay, usually we control the operation of the instrument using the computer. Okay, and significantly reduce the time spent on each analysis. Once you inject your sample in the instrument, you can get your results using the computers. So it is very fast, and that's why we can reduce the time spent on each analysis. Compared to titration, you have to do the titration, you have to do the calculation manually. So that one will require more time to do the analysis. Okay, compared to an instrumental analysis. And then this instrument, of course, we use automation. And this automation help in accurately and rapidly performing routine analysis. So imagine in industry, they have analysis lab. They need to do a routine analysis. Every day there are 100 samples come in, okay, and they have to do it to do the routine analysis. They need an accurate and rapid method. So they will go for instrumental analysis. Okay, the results can be used to automatically control the process. Since we are using computers, they are automatic. So this is what means by the automation. Everything's are automatic set using the computers. And then the process control apparatus is useful when judgment must be made rapidly or when the sampling or control process is unsafe. Okay, let's the instrument do it for you. Okay, since if the sampling and control process is unsafe for human, so um, the instrument or the robots will do it for you. Biasa kita panggil robots lah sebab dia bekerja untuk you kan. Tapi bentuk dia macam instrumen biasa. Alright. And to choose a suitable analytical method, okay, you need to consider these factors. Okay, the factors that should be considered when choosing an analytical method. Okay, you want to choose, there are so many analytical methods available in lab, in industry, so you need to choose based on these factors. Okay, so what type of readily available instrument in your lab? Okay, kita tak adalah nak beli yang baru kalau tak sesuai. So kita kena sesuaikan dengan instrumen yang dah ada di lab. So experience of the analyst in using a particular instrument. So usually when you send your sample for analysis, there are analysts that are going to do the analysis for you to operate the instrument. So is there any experienced analyst in the lab to do it for you? Okay, if not, so you might need to consider other instrument. And then expected concentration range. Some instrument only can detect high concentration of analyte. Some instrument can detect very low concentration of analyte. The sensitivity depends on your analyte concentration. Okay, so you need to know what is the expected concentration range and you need to choose a suitable instrument based on this. Okay, similar to required precision and accuracy, any potential interferences in your sample, number of samples, okay, rate at which the results must be obtained. Some instrument can give you very fast results. Okay, some need a few days. Okay, so you need to consider all these factors. And also the last one is expenses of each essay and the entire analysis. Some instrument is very high cost. Okay, some instrument is very cheap. So you need to consider all these factors when you want to choose the suitable analytical method. Okay. Right, so there are three major categories of instrumental methods, okay, for chemical analysis. Okay, we have instrument under spectral methods, we have instrument under electroanalytical methods, and we also have instrument under separative methods. So these methods, okay, is used for different kind of instrument. Kalau instrument tu, if the instrument use or measure some form of radiation during the assay, so um, if your instrument are going to use radiation, tak nampak, sorry. Warna apa warna merah. Okay, kalau dia guna radiation, dia under spectral methods. Okay, so what is the radiation we are going to look at after this? Next, if the instrument apply an electrical signal to the sample and or monitor an electrical property of the sample, any instrument apply electrical signal, or you monitor the sample using the electrical property. Okay, so it is under electroanalytical methods. Okay, and the last one, if the instrument rely upon separation of the components, the instrument able to separate the components of a sample prior to measuring a property of the components, so it will be under separative methods. So if let's say if you have 2 or more compound in a sample, and the instrument can separate those compound, okay, and it can detect each of the compound in the sample, so it is under separative methods. Right. So let's go one by one. Spectral methods just now. Okay, so the spectral methods of analysis use an instrument to measure the amount of radiation that is absorbed, emitted, or scattered by the sample. Okay, if the amount of absorbed radiation is measured, the technique is absorptiometry or absorption spectrophotometry. Except for naturally occurring radioactive materials, radiation can be emitted from a sample only after the sample has absorbed energy from an outside source. Okay, so the the sample that you have, okay, it can absorb, emit, or scatter the radiation, and the amount of that radiation measured by an instrument, so that instrument will be under spectral methods, will be classified under spectral methods. Okay, so what is the radiation? Okay, so radiation is the interaction between electromagnetic radiation and matter as a function of the wavelength or frequency of the radiation. Ini textbooks lah. Okay, so spectral methods, when the light, okay, or electromagnetic radiation kita panggil juga sebagai light, okay, interact with matter. What is the matter? Any solid, liquid, or gas, okay, anything in your surroundings are matter. Okay, so when the light interact with the matter, okay, this light, it is either absorbed by the matter, emitted, or scattered, okay, and there is a frequency of radiation that will be measured by the instrument. So that instrument will be classified as spectral methods. Okay, so what is the light ataupun electromagnetic radiation? So light, we have few classification. We have visible spectrum that you can see with your eyes, okay, and then we also have gamma rays, X-rays. Okay, kalau you pernah dengar you pergi X-ray apa untuk masuk UMP you kena buat X-ray kan, yang tu under light jugalah, one of the light. Okay, We have UV, ultraviolet. We have visible spectrum. Nama dia visible sebab kita boleh tengok dengan mata kasar. We have infrared. We have microwave. We have radio wave, whether it is FM or AM. And then we have long radio wave. So these are lights. Okay. And then matter, just now I said everything around you is matter. So matter is anything that has mass and takes up space. There are different states or phases of matter. Okay, it can be solid, liquid or gas. So changes can occur between these states. Okay, solid can be liquid, liquid can be gas, right? So that is matter. So let's look at the interaction between the light and the matter. Oh, this one PDF, so tak boleh play video lah. Tak apa, you guys boleh go through. Okay, so the interaction, you will see whether the matter, the matter can absorb, emit or scatter the lights. Okay, so that is the principle, the concept that you need to understand. Okay, so for example here, the white light from the sun, okay, consists of few colors, right? So rainbow color lah. So this white light contains all the wavelength. Okay, but once it interact with the matter, so this apple is one of the matter in solid form. So when this apple reflect only red color, your eyes can only see red color. Okay, yang lain tu dia absorb lah ataupun dia emit. Emit ni dia ke sini. So yang you nampak adalah dia transmitted. Okay. Itu konsep. Okay. So spectral methods. Okay, sometimes we call it as spectrophotometry. Okay, these are the instrument under spectral methods. Is in the ultraviolet and visible region. Those in ultraviolet and visible light, okay, we call it as spectrophotometry instrument. Okay, so this is the wavelength of UV and visible light. Yang ni tak perlu hafal lah, you just faham. Yang ni semua adalah light. Okay, with different wavelength. Those that you can see with your eyes is visible light. Okay, type of instrument under spectral methods. Okay, we have atomic level and molecular level. So for atomic level, we have atomic absorption spectroscopy. Those with the name spectroscopy, okay, sometimes tak ada, tapi biasanya kalau ada kat belakang ni memang dia classified under spectral method. Spectroscopy. So it is the interaction between light and matter. Okay, and for molecular level we have UV spectroscopy. Yang ni you guna dekat lab kan. Okay, yang ni classified under spectral method. So it is there is an interaction between light and your sample. Okay, and we also have others, and the familiar one will be Fourier transform infrared spectroscopy. Ini kalau you buat final year project, you akan jumpa lah. Okay, diploma saya tak pasti sampai tahap mana, tapi degree, this one will be very familiar. Yang ni pun sama kalau you ambil organic chemistry, kalau you buat FYP dengan organic chemistry, you akan guna nuclear magnetic resonance spectroscopy. Okay, so that one is analysis through spectroscopy. Okay, and then we also have analysis through thermal energy X-ray techniques, and also microscopy. Okay, and there are different types of instrument under each type of analysis. Okay, and these are still under spectral methods. Okay, and the second type second type of analytical chemical analysis method, okay, instrumental method is electroanalytical methods. Okay, as we already go through just now, and the electroanalytical methods are those instrumental methods of chemical analysis in which either an electrical signal is applied to one of the electrodes dipping into the sample solution, or an electrical property of the solution is measured. So those use an electrical signal to electrodes dipping into the sample solution is classified under electroanalytical methods, or the electrical property of the solution is measured, still under electroanalytical methods. Okay, kalau sebelum ni tadi cahaya, interaction between light and matter. So we measured the radiation. Kalau electroanalytical methods, kita measure electrical property, okay, of the solution. So the electroanalytical methods are divided into categories according to the type of electrical measurement that is made and type of applied electrical signal. Okay. So here, okay, we have divided into the type of electrical, whether it is applied or measured. So electroanalytical methods, okay, electrical contact with the sample is completed by dipping at least 2 electrodes into the solution. Okay, and if the potential between the 2 electrodes is controlled and the current is measured. Okay, potential is controlled, current is measured. So, So we call the instrument as amperometry. Okay, so current is measured. Potential is controlled. So it is called as amperometry. If the current between the electrodes is controlled, sekarang kita control current. Potential pula kita measure. Terbalik dengan amperometry tadi, we call it as potentiometry. Okay. And then we have electrical conductance is measured. Okay, lain tadi potential measured, lepas tu current measured, lepas tu sekarang electrical conductance measured, we call it as conductometry. Dia adalah, kalau you perasan, dia ada keywords dia kat situ, conductometry, conductance. Okay, so potentiometry, potential measured. Cuma yang ni lain sikit lah, current measured tapi kita panggil amperometry. So biasanya bahasa Latin ada kaitan lah. Okay, next we have either a potential or a current can be applied to the electrode in the solution. Salah satu. Kalau nak potential lah. Kalau nak current. So kalau salah satu, we call it as coulometry. And when we apply potential or we apply current, we measure the quantity of electricity for coulometry. Okay, next, we apply potential and the current flowing through the electrode is measured. So yang ni specific to potential. Okay, kita still measure the current, but now the current is flowing through the electrode. So we call it as voltammetry. And the last one, similar to coulometry, you either apply potential or current, but now you measured mass. We call it as electrogravimetry. Okay, kalau you tengok tadi coulometry, either potential or current being applied, but the measured one is quantity of electricity, we call it as calorimetry. If the mass is measured, we call it as electrogravimetry. Okay, so you need to remember this one. Okay, so the question might ask you to choose the correct instrument based on the where the potential, current, conductance, mass, quantity of electricity is measured. Right. So that is for electroanalytical methods. And the last one is separative methods. Okay, for separative methods, as I said, the instrument able to separate the components in a mixture based on the physical or chemical properties. Okay, we have classical separation methods. For example, distillation, extraction, precipitation, filtration, osmosis, and reverse osmosis. Okay, this one is a classical separative methods. And then we have advanced separative methods. Okay, so we can classify under 3 types of instrument for separative methods. Okay, we have chromatography, where a mixture is separated into its component as a result of the relative ability of each component to be flushed along or through a stationary phase by a mobile phase. Okay, in this chromatography instrument, they have column. Okay, column where your analyte will go through this column, and in this column they have stationary phase, static. Okay, so this stationary phase will separate your analyte, your mixture, okay, into a component based on the physical or chemical characteristic, and mobile phase will bring your analyte to the detector. Okay, so kalau you ada 3 analyte, 2 terperangkap kat sini, lambat sikit nak keluar, yang satu akan jalan dengan mobile phase, usually solvent. Solvent will bring the one component that is not attracted to the stationary phase. Okay, so dia akan first detect lah. And then these two, yang mana akan jalan dulu depends on the physical and chemical properties of the analytes. Okay, so that is chromatography. There are stationary phase in the column, static phase, and there is a mobile phase, usually solvent to bring your analyte to the detector. And there are 2 types of commonly used chromatography in the lab or in industry, which is liquid chromatography and gas chromatography. There are so many, but these 2 are very famous. Okay, and then under separative methods, we have another types of instrument categorized as electrophoresis. Okay, so the separative method that takes advantage of the relative mobility of ions towards an electrode of opposite charge, okay, and away from an electrode of similar charge. So this electrophoresis deal with ion. Okay, so the mobility of the ions towards an electrode of opposite charge. Okay, and it is away from electrode of similar charge. Yang ini you boleh bayang kalau magnet lah, sama kutub menolak, lain kutub menarik kan. Okay, sama juga ion. Positif dengan negatif tarik, kalau sama-sama positif dia menolak. Okay, so this is the concept of electrophoresis. Okay, the separation based on the charge of the ions. Okay, and the last one we have mass spectrometry. So mass spectrometry, the name with mass in front. Okay, of course you will deal with the mass. Okay, so this mass spectrometry based upon the relative motion in an electrical or magnetic field of the components of a gaseous mixture of samples ion. So the relative motion of each ion is dependent upon the mass to charge ratio of the ion. Okay, so the separation of the ion is dependent on the mass to charge ratio of the ion. Okay, what is the mass to charge ratio? It is related to the atomic mass or molecular mass in the periodic table. Okay, so that is all about the instrumental analysis that you guys, diploma student, need to know. Right? So that is the end of our chapter 9. So thank you very much. Please proceed with your assignments. Okay? And then please prepare for your final exam as well. Okay, so I'm really sorry that we cannot do the face-to-face class. Okay, but I hope this recording might help you to prepare for your assignment and final exam. If you have any questions regarding these two chapters or other chapters, you can let me know. Okay, via the group, personal message, or you can also email me if you have any questions. Right? So thank you very much, guys. I hope to see you again. So thank you very much, guys. Have a nice day. Bye.